Okay, now let's get back to our discussion of polynomials after we've had some discussion of complex numbers, because we're going to need to use those complex number ideas when discussing polynomials. The notation that I'm using is that I'll refer to the order or degree of the polynomial as being n, and depending on what this subscript is, and here it's a 2, that will determine the order or degree of the polynomial. So if I have p sub 2 of x, I'm talking about a polynomial of degree 2. Here's an example, x squared plus 3x plus 2. Now this polynomial can be factored and factored into x plus 2 times x plus 1. Now, whenever we're working with polynomials, almost always what we are interested in is what are the roots of the polynomial. The roots are those values of x for which the value of the polynomial p of x is equal to 0. So what values make this polynomial equal to 0? If we write it in the form of the product of factors, it's pretty clear that if x is equal to negative 2, that this term will equal 0, and it will make the entire polynomial be 0. Or if x is equal to negative 1, this factor will be 0, and it will make the entire polynomial be 0. So the two roots of this polynomial are x1 equal to negative 2 and x2 equal to negative 1. So here are our roots of the polynomial. However, sometimes a polynomial has roots that are not real valued. Here negative 2 and negative 1 are real valued. Sometimes a polynomial has roots that are complex valued. So let's look at this polynomial here. Again, a second degree polynomial. This is x squared plus 2x plus 5. Here, it's not obvious looking at this polynomial what the roots are, what values of x make this thing equal to 0. In fact, if we were to plot this on an xy plot, we would see no values of x that make it equal to 0. Let's look at let's now do what's called completing the square to find the roots. Okay, so here's the polynomial right here, x squared plus 2x plus 5, and I bring the constant 5 over to the other side of the equal sign by subtracting it from both sides of the equation. So I now have x squared plus 2x equal to negative 5. Now I want to find the constant that I add on to x squared plus 2x such that the remaining factor is a perfect square. So let's look at this. I do x squared plus 2x and I add 1 to both sides of the equation. So here's a plus 1 and here's a plus 1. Now this term right here is exactly equal to x plus 1 squared. So this is a perfect square, and this is equal to negative 5 plus 1, or negative 4. So I have x plus 1 squared equal to negative 4. I take the square root of both sides, it gives me x plus 1 here, and this becomes plus or minus the square root of negative 4. Okay, so I have x plus 1 equal to the plus or minus the square root of negative 4. I subtract 1 from both sides of the equation, and it gives me the value for x. X is equal to negative 1 plus or minus, and the square root of negative 4 is 2i, plus or minus 2i here. So this is a complex number. It's negative 1 plus 2i, or negative 1 minus 2i. So the two roots for this polynomial up here, this polynomial right here, the roots are x1 equal to negative 1 plus 2i, or x2 equal to negative 1 minus 2i. And in general, we can have complex roots to the polynomial. So that leads us to our next discussion about polynomials, where instead of implying that the variable x is just real valued, we are going to allow the variable x be complex valued. Now, just before I do that, I needed to do that discussion of complex numbers, and hopefully you have enough knowledge of complex numbers now to continue this discussion of polynomials.